Hi, and welcome to the third video in the Deephaven Learn series. In the first two videos, I introduced Deephaven Learn and the Gather, Compute, Scatter paradigm. In this edition, I'll be diving deeper into the gather step of that paradigm. In terms of Deephaven Learn, the gather step requires a user to collect a defined subset of data from a Deephaven table into one or more NumPy arrays. This step is critical because it's where you can define the optimal method for taking raw input table data and converting it to exactly what your model needs. Let's look at the code I have at the bottom of the screen. I have two Deephaven imports. In this case, I need Deephaven Learn, and more importantly for this video, I need Deephaven Learn Gather. The Gather submodule defines some critical functionalities. The first of which is the table to NumPy 2D method. This method is how you will collect table data from sets of rows and columns. It will additionally define the desired memory layout of the output NumPy array, as well as the data type in the output. The second is the memory layout class. This class can be initialized with either a true or a false. True denotes row major order, while false denotes column major order. These values can have an impact on performance during the compute step. For more information about that, check the video description below for a link to a brief article I wrote that discusses how array contiguity affects code runtime. After that, I have two functions. These are good examples of what a gather function can look like in a real application. The gather function will always take two inputs, a set of rows and a set of columns, which I've aptly named. The gather function should also return the output of the table to NumPy 2D method, or some modified version of the output of that method. Gather's table to NumPy 2D method can take up to 4 input arguments. The first, second, and fourth are required, while the third is optional. The first and second arguments are the rows and columns which will be gathered from the source table. We'll specify exactly which rows and columns during the learn function call, but I'll cover that down the line in a few videos in this series. The third argument is the order. This argument is optional, as the default is row major. For static queries and queries on small data, this won't likely have a huge impact on code runtime. However, for big and real-time data, the array contiguity can make or break a query. The fourth is the data type. This argument is required, as it sets the data type of the output NumPy array. There is no default type, so it's required to specify this. I personally prefer to have one function per data type I need in a given application. The output of both of these functions will be a two-dimensional NumPy array that has structure identical to the subset of rows and columns in the table from which the data was taken. Even if you only gather one row and one column, that singular value will be stored in a 2D array with one row and one column. Gather's table to NumPy 2D function was built with the fastest and most memory-efficient methods in Java, so that it can keep up with high volumes of dynamic data. We at Deephaven are looking to expand the capabilities of the Gather submodule to higher dimensional data, so be on the lookout for future announcements and demos related to that. That's the basics of the Gather step of Deephaven Learn. Check the video description below for relevant links and information. Like the video and subscribe if you enjoy our content, and thanks for watching. I'll see you in the next installment, where I'll cover the basics of the compute step.